Welcome to series of organic chemistry. This is class number 6. It is a continuation of class number 5. Today I am going to sum up the amine chapter, and the part is known as chemistry at a glance. Means within a very short time I am going to complete the whole chapter or sum up the whole chapter. First of all, amines are used in vitamin, protein, alkaloid, hormones. They are used in the industry. Also, adrenaline and ephedrine are used in increasing blood pressure or in cardiac arrest. Novocaine is used as anesthetic in dentist or dentistry. Next, histamine or histidine as antihistamines used in rashes, allergies, insect bite. So these are some uses of compounds containing amine. Now, structure. It is sp3 hybridized, bonding rule is 108 due to the presence of lone pair of electron. Now, the reaction, I am brushing up what type of the reactions are being used during preparation and during its reaction. Preparation. Number 1, C2H5 NH2 ammonia. C2H5 I ammonia, then C2H5 I C2H5 positive to NH. Likewise, it is 1 degree, it is 2 degree, it is 3 degree. The process was called ammonolysis. Number 2, the Briel-Thalamite reaction. It was like this. Then at last sodium hydroxide. RNA. Mind that it was amine, and it is only primary amine of type 1 degree primary amine. So in this process we cannot produce, we cannot get primary amine, aromatic primary amine. Aromatic alkyl halide cannot be easily substituted by this method. So that was second. The third one is amide, bromine potassium hydroxide, Hoffman bromobard reaction. Then fourth one from reduction of cyanide group. Reduction of cyanide group, lots of things were there. RCN reduction, hydrogen, nickel, palladium, platinum, anything. So that was R CH2 NH2. So one important thing is that whenever cyanide group is there, we get one excess carbon, and that C becomes CH2, then you get NH2. Again, that can also be reduced by sodium ethanol. Again you will get let's see SCH2 and NSNH2. Again you will get RCONH2 on reduction like lithium aluminum hydride. There you will get So here again that CO group changes into CH2. Again if your cyanide is isocyanide and if you make reduction you will get 2 degree. It is very important, 2 degree. And if it is like this, and if we use base, then here this is base. It abstracts one hydrogen from this one, and this bond withdraws in this way, and we get 3 degree amine. This is elimination type of reaction. Again, this is all about the reaction involved in the preparation of amine, 1 degree, 2 degree, 3 degree, etc. Now, what were the reactions involved? The reactions were first alkylation. We have done it already in ammonolysis. 2 number acylation. Also we have done it in the first 5th number of classes. Number 3, amine reacts with Grignard reagent. So we got it in this way. Alkene, and again nitrile Goupart compound containing Cl reacts with Grignard reagent. This is Grignard reagent. This is Grignard reagent. So here the reaction is a bit long, but we get here is ketone. Next type of reaction was nitrous acid, amine with nitrous acid, that gave this aromatic amine, this aniline with nitrous acid, that gives benzene diazonium chloride. Next one was Hinsberg reagent, C6 H5 S vinyl chloride plus secondary amine, we got the answer is like this. And this is Hinsberg reagent. And that reacts with amine having hydrogen, that is 1 degree, that is primary and secondary amine. If it is 3 degree amine, it will not react with this one. Hence Hinsberg reagent is used for distinction of 1 degree, 2 degree and 3 degree amine. Yes, next reaction is reduction of nitro group. Nitrobenzene that is aniline, and if it is still HCl, same reaction occurs. Next one is C6H5COCl plus aniline The answer is C6H5COONH. This is benzol, BENZOYL, benzol chloride, and this is benzene diene. So in earlier class I told you benzoyl and benzyl, so you keep it in your mind, the nomenclature. Next one is coupling reaction. Plus that is benzene diazonoyl chloride and phenol, coupling reaction we get. Once again, that is para-hydroxy azobenzene. That group is azo. So para-hydroxy azobenzene, same compound, same type of coupling reaction, benzene diazonium chloride plus, if you use aniline, again another coupling reaction occurs, you get para-amino azobenzene. Its color is yellow, its color is orange. Very often asked in entrance exam or any other exam, what is the color of this final compound. So next one is, and the special name is cotton bound reaction. I have done it earlier. The next part is amine, chloroform, potassium hydroxide. That part become isocyanide compound, very important reaction. Next one is bromination. Aniline in presence of water means aqueous. Bromine, aqueous, it gives this compound, it is 5 ppt, and this is unprotected. Due to activity of NH2 groups, we get 3 bromine in the ring. Substitution of 3 bromine, electrolytic substitution occurs unprotected. So if this group is protected, always protection is done. Amine group is protected. If it is protected amine group NH2 group, it is done with this. So first happen, we get this part. In replacing one hydrogen, this part enters here. One hydrogen from here is replaced by CH3CO, CH3. That's why the activity of NH2 group is decreased. And if we use now bromine and acetic acid, we get para-substituted product as measure. Para-substituted product as measure. There is one part more, acid or base. I have not shown it. Acid and base part is there. I have not shown it. In the same way, aniline when nitrated, HNO3 plus H2SO4, we get NO group. Again we get NH2, NO2. NO2 comes from this. It is electrophile, and NH2, Na2, that is called tertiary oxidation. Tertiary oxidation means unwanted substituted product occurs when it is not protected. Unwanted means it is due to the fact that HNO3 and sulfuric acid both are strong acid, but sulfuric acid is stronger than nitric acid. So nitric acid can be written as this, and one hydrogen from this get attached with this one. One hydrogen from that acid get attached. Means HNO3 protonated. So also amine is also protonated. NH2 it protonated as this. So we are getting two things in presence of this mixture. If it is not protected due to activity of this one, the presence of HNO3 sulfuric acid, NH2 group becomes NH3 means amine, aniline gas gets protonated as this, and HNO2 gets protonated like this, and this becomes water. You are getting NO2 electrophile. So due to this fact, we get unwanted substituted product. So if you want to get desired product, then we need the protection of this NH2. So if you want to protect this NH2, then earlier we need to treat with this. Am I right? One hydrogen is replaced by this NH, one hydrogen replaced by that group. That's why the activity of NH2 group is decreased. And if we now use nitrating mixture, that nitro groups comes, and on acid and base, I am not showing this part. Acid or base gives you amine part, and major nitroaniline appears. So first one is a bit earlier I have shown, it's unprotected. When nitric acid and sulfuric acid are used alone, without any protection, we get ortho, meta, and para product. It is unwanted substituted product due to the presence of sulfuric acid, the strong acid. The NH2 group is protonated, so also HNO2 is protonated. Due to this fact, we get terioxidation. And if this group is protected, we get the desired product NO2, para nitro aniline. So in this way, if you use sulfuric acid alone with aniline, sulfonation, H2SO4 concentrated, the reaction occurs like this. On heat temperature of about 400 above, we get this one, and it is always in equilibrium position. It is deprotonated, it is protonated. From this it is protonated, from this it is deprotonated. One hydrogen is removed, deprotonated. One hydrogen is added, protonated. From this, if you assume this one hydrogen is released, deprotonated. One hydrogen is added, protonated. So protonation, deprotonation occurs, and this is called JEE IIT. This is called JEE IIT. So now, one of the fact in entrance exam, very often a question asks, so what is the electrophile being produced when sulfuric acid concentrated sulfuric acid is used? So very often we get the product is like this. We get the product like this. So when we see this part, this group, we very often give the answer that SO3 is the electrophile, but answer is wrong. SO3 is not electrophile. I am showing you a bit details. What happens here is, when sulfuric acid is added, say concentrated H2SO4, sulfuric acid molecules, so what's the happened here? OH comes here, so OH2. To write here HO S double bond O OH2. So that one I have written as this. I have written that one is this on getting one proton from this. We get this one, and that one remains as this deprotonated OH S double bond O negative. OH S double bond O negative. HSO4 negative. So that OH means as water release, and that bond is withdrawn here. So what's happened here is O double bond S double bond O plus water, and that hydrogen remains like this. So what you get is SO3, and that SO3 is electrophile. So in nitration of benzene or aniline or anything, when sulfuric acid alone is there, the reaction occurs in this way, and the electrophile is actually SO3. So in the option, SO3 is electrophile is generally given, and another is HSO3 that was given. So very often the student gives the tick mark to this one. Answer: electrophile here is actually SO3, as I have shown. Now let us discuss in short benzene diazonium chloride. You may give it X, okay. Answer is chlorobenzene that comes from this one, and X will come out like other side part. And if this is Cu2 Br2 HBr, answer is bromobenzene. If this is CuCl, answer is cyanobenzene. And if one step more, if you proceed acid hydrolysis, it is very important. Very often in conversion reaction this terms comes. Cyano group, CN group becomes COOH. CN group becomes COOH on acid hydrolysis. So what you get is, this is Sandmeyer reaction. Sandmeyer reaction. These reactions are Sandmeyer reactions. So now what's happened? Now further, if you give water and warm it, very often this question comes, you will get phenol. If you give purity and orthophosphoric acid, you will get simple benzene, and this will become oxidized. And if you give CH3 CH2OH, then this part oxidized. Your answer will be again phenol benzene plus CH3 CHO. This part is oxidized only. And if you do in this way, it is iodobenzene. If you I am jumping the steps, it is fluorobenzene. And if it is HB F4 Na Na2 copper, heat, answer is nitrobenzene. This is Boltzmann reaction. Earlier I have shown you. So this is all about the reaction. Takes part in a short in amine chapter. Let us now apply how this all type of reaction helps in solving out the problem. You will apply the concept what you have learned in mind, apply your mind concept in solving out the practical problem. Let's see. CH3 I KCN, that is then OH partial hydrolysis and then bromine so this is very simple one. When cation is there, just you replace this one CH3 CH2 Cn. On partial hydrolysis, that Cn group become CH3 CO NH2, that is amide. And when there is bromine and base, it is a degradation reaction. Hoffman bromamide degradation reaction. I have done it earlier, so that part will become one carbon atom is less, one C is less in it. Hoffman degradation. The answer is this. Only part is that partial hydrolysis of this give you amide, and full hydrolysis of Cn in acid medium will get COOH. Cn on acid hydrolysis gives you COOH, and Cn on partial hydrolysis gives you amide. Just you keep it in your mind, otherwise you can't do this reaction. Next one is C6 benzene diazonium chloride. Benzene diazonium chloride CuCN. We have done it earlier. I will apply this, that, and on acid hydrolysis it gives B, and next on ammonia and head heat it gives this. Just you follow, very simple one, very simple. When benzene diazonium, we have done a bit earlier in Senmeier reaction, when benzene diazonium chloride reacts with Cu2 Cl2 HCl, we get chlorobenzene, other time bromobenzene, other time cyanobenzene. So if this is Cn, so we will get cyanobenzene, and if it is acid hydrolysis, I have just now told you cyanogroup on acid hydrolysis becomes COOH. So you are getting COOH. When ammonia is there, we are again going to the carboxylic chapter. We have done it. It get attached with this one. So you are getting COOH NH4, and here heat is given, means when you heat it, so water molecules leave out from this one, H2O. So you are getting this. Very simple. Very simple. If you know the reaction, if the reactions are in your hand, then all the conversion, all types of ABC which very often asked in your exam will be in your hand. Surely will be in your hand. So next one is CH3 CH2 there KCl. Answer A. That is lithium aluminum hydride. Answer is B. And then nitrous acid. I have done a bit earlier. Reaction of amine with nitrous acid gives alcohol. So what is, let us solve it. When casein is there, we will just convert it CH3 CH2Cl. Now reduction of CN group. We have done reduction of CN group in 3 ways in our chapter. One is H2Ni or platinum, another is NaC2H5OH, other is lithium aluminum hydride. Lithium aluminum hydride is a Bendius reaction. Lithium aluminum hydride. All types of reduction gives you increase of one carbon in the reduction process. So we are reducing this Cn, that this Cn, here C will become CH2. So what we are getting here is CH3 CH2 is as earlier, we have written the same, and this Cn, that C becomes CH2, C becomes CH2, and here we get amine. This is reduction, lithium aluminum hydride. Now next one is nitrous acid. So nitrous acid may be Na2, in your exam it may be written in this way, may not be given HLO2, may be given in this way. So it is very simple. It gives you benzene diazonium, alkyl diazonium chloride, and on hydrolysis on water you will get alcohol. So I am jumping the step, CH3 CH2 N2 Cl negative, and on water we are getting alcohol. Next one is C6H5 NH2 T HCl A. Next Na2 HCl B. Next one is water 1. Again very simple. I think this should be nitro. So nitro group, at the very first of today's class, very beginning I give you SnCl and FeHCl. Both are reducing agent. So nitro become NH2, C6H5 NH2. Nitro become NH2. Now just now I have shown you Na2HCl, it is nothing but nitrous acid. It is nothing but HNO2, and it gives you benzene diazonium chloride, C6H5N2Cl negative, and on warm with water gives you phenol. I have just shown you a bit earlier. Again very simple. So if you know the reaction, all reactions are in your hand, no conversion, no fill in the blanks will be left out, you can do yourself. And next one is acetic acid, CH3 COOH ammonia gives A, and NaOET, ET means ethyl part, gives B. Next, Na2HCl, Na2HCl, again very simple. In carboxylic acid groups, you got this attached CH3COONH4, and if it is heated, it will water molecule release out. You are getting CH3CONH2. Am I right? So when you get gives sodium, this one, again you are C1 amide groups becomes amine, amide groups become amine, and when you are using sodium nitrate plus HCl means HNO2, you are getting alkyl diazonium chloride, and on water you are getting methanol. Again and again you are getting the same reaction. Next one is C6H5NH O2 gives A in presence of NaCl, and HNO2 gives B, and C6H5OH gives C. So again I have done it, already I have done it. Just to see, this is nitrobenzene. Nitrobenzene on reaction of this one, this is reducing agent, this is reducing agent, so NO2 becomes NH2, C6H5NH2. Let me write in this way. You are getting this. Am I right? So on reduction with SnHCl, NO2 becomes NH2, and with HNO2, nitrous acid, you are getting diazonium chloride. Now this diazonium chloride is again reacted with phenol. So what I drew here is, let me arrange it in this way. Diazonium chloride, and that is phenol. Let me write this in this way. Then you can recall what type of reaction it was yourself. Is it not coupling reaction? You are getting N double bond N, that is para-hydroxy azobenzene. Para-hydroxy azobenzene. It is orange in color. I have shown you at the very beginning when I speedily did all the reaction within a very short time. So reaction of amine at a glance. Reaction of amine at a glance. So next one is aniline C6H5NH2 plus bromine, potassium, no, that was chloroform and potassium hydroxide. That reaction is very simple. At the very beginning I told you, if chloroform potassium hydroxide in amine is there, then it is Karba-Lehmann test. Karba-Lehmann reaction. Isocyanide will become it will become isocyanate. Fishy and foul smell, isocyanate compound. So you are getting this one. So it is very one part is given, aniline CH3CH. When you see chloroform and potassium hydroxide, then that becomes C. NC, sorry, NC. NC. Isocyanate. Fishy smell, foul smell. Next one, benzene diazoxide chloride. Very simple. Again, I have done it. Benzene diazoxide chloride, and you are giving orthophosphoric acid, and heat. You are asked only one step reaction. It is nothing but this, and this will become this. I have shown you at the very beginning. Benzene diazoxide chloride, orthophosphoric acid. This will be benzene, and phosphoric acid, orthophosphoric acid will oxidize at H3PO2. I have done it already. I have done it. So next one is aniline. This is aniline H2SO4 concentrated. I have done it already because para-substituted product. I have done it, and I have shown you deuter ion also. Yeah. Sulfonic acid will enter in para position. I have shown you. I had earlier mentioned it. Next one, benzene diazonium chloride ethanol. Benzene diazonium chloride CH3 CH2O. I have already mentioned that will become benzene, and that part will oxidize CH3 CHO. C6H5NH2 plus bromine aqueous. I have shown you already. This will be like this 5 PPT compound. 2,4,6 tribromo aniline. Next one is benzene diazonium chloride C6H5, benzene diazonium chloride HbF4 NaNO2 copper heat. Very simple. Answer is nitrobenzene. Next one is that reacts with Br2 sodium hydroxide. So you see, this is amide group and bromine sodium hydroxide. Hoffman bromamide reaction, that part will leave out. Other part will remain same. And next part is chloroform potassium hydroxide. Again, I have shown you when amine is there and chloroform is there, this is carbyl amine reaction, and that part will become, other part will remain same, only that part will become NC, isocyanate. Again, another part is given. This is reduced with palladium and hydrogen. So in my first chapter number lesson number 4, I have shown you, if it is cyanide, if you reduce it, you will get amine, and it is first degree amine. If it is isocyanide, then you will get secondary amine. So here this part there is one part alkyl part, cycloalkyl part, and other part you will get another CH3. So you will get like this. One hydrogen is there, 1, 2, 3. So it is secondary. This part, one hydrogen is there, secondary amine. So mind that whenever isocyanide is there, you will get secondary amine. Next one is A, and when it is made to react with hydrogen, you are getting B. So simple, when you are reacting with this one will enter here, you will get that your A is over and A part is over. You are reducing it with hydrogen, am I right? So that Cn will part reduced, here it will be CH2 and that will be amine. So on reduction of Cn, we always get C becomes CH2 and that becomes NH2. One CH2 group enters in reduction of cyanide increases, but in nitro group if you reduce, no CH chain is increased. So your answer is this, that becomes CH2 and that becomes NH2. So this is all about the reactions, solution of the reaction of the chapter involved as per the textbook is concerned, and in my next class I will continue another new chapter.